Hi there, today we'll be going through projectile motion, and to first go through that, we must first learn what motion in a plane means, and to first go through that, we must know the basic kinematic equations. So now, two-dimensional motion is nothing but two separate cases of one-dimensional motion. So here, as you can see, when a particle moves on the xy plane like so, it moves on the x-axis as it moves on the y-axis. So the shape it traces out is nothing but a combination of the x and y movement. So just like that, we can treat the position and the velocity of the particle as two different cases of one-dimensional motion. The first being the x-axis and the other being the y-axis. So in the x-axis, we would write x is equal to x0 plus ut plus at squared divided by 2. Now here ut refers to u in the x direction and at refers to a in the x direction. Similarly, we can write y is equal to y0 plus uy t plus ay t squared divided by 2. Now, in both the cases, well, in our case, for our purposes, we treat x0 and y0 as 0. So the equations come out to be as such. Now, moving on, the next step is going to be to define ux and uy in our projectile motion case. So if we have the y-axis like that and the x-axis like that, and we project an object at a velocity u at an angle theta from the x-axis, then we can define velocity. Before that, we first need to define velocity in x and y. So just like we did in the case of position, we can define velocity as vx is equal to ux plus ax t, and vy is equal to uy plus ay t. Now, we first have to note that in our case, there is the acceleration of gravity downwards perpendicularly on the object at all times. And since we are neglecting air resistance, we have no acceleration in the x direction at all. So now we have vx is equal to ux plus 0t, so that's just 0. Now if we see how the vector u is projected on the x-axis, one will note that this is just u cos theta, and we similarly uy is just u sine theta, and therefore we can further, so this is going to be our equation, this is going to be equation 1 and this is going to be equation 2. From here we can say that vy is equal to u sine theta plus ay is just gravity, which is downwards, so that is going to be negative gt. There we have it, the equations for the velocity in the x and y axis for projectile thrown at an angle theta. So we're going to mark that, and using our knowledge here, we can simplify the position simplify the position functions too. We can specify that this, for a projectile, this is just going to be u cos theta into t, and plus, so since there's no gravity in this, we won't have another term. This, on the other hand, is equal to u sine theta t minus gt square divided by 2. So there we have it. Now we can finally write our final equations for projectiles, which is going to be as such. Now we can begin removing the t variable from both the equations for the position on the x and y axis. We will first begin by writing it out like this. So as you can see, both of these equate to the same thing, so we can therefore set them equal to each other. So x divided by t cosine theta is equal to y plus gt square divided by 2 whole divided by t sine theta. Now we can, so this is going to be our equation number 1, and then we can start equating it for we can start simplifying things down. So this will be equal to t sine theta x divided by t cos theta x, which will be equal to y plus gt squared divided by 2. Now we can remove all of this and make it x tan theta equal to y plus gt whole square. Now if we go back up, we can see that in our equation over here we can simplify this. In our equation over here, we can simplify this to be x divided by u cosine theta equal to t. Now we can use that to remove the t square variable over here. So this just becomes x tan theta minus g t square. So g t square is just x over u cosine theta. So that's just so now that we have that equation, we can simplify it further. And that right there gives our equation for the parabola that is formed when a projectile is thrown at an angle theta with a velocity u. Now that we have the following equations, we can easily find out various points in the flight, such as, first of all, let's draw a simple parabolic trajectory for a projectile. So it should be something like this. So this is going to be our, so it should be something like that. That's the x-axis, that's the y-axis, and that is the origin. Now that is going to be the vector u at which the projectile is thrown. That is going to be the angle theta. First of all, we are going to find at what time the projectile has completed half of its trajectory. So this, let's mark that. We go, the time at that point, let's call it Tm, right? So we got it. So we will now look at what time is the projectile at its highest point. So that is going to be somewhere over here. So that is exactly in the middle of the trajectory. So we're going to call that time Tm. So now at time Tm, since it is the highest point in the projectile's trajectory, we won't have any vertical velocity over here. Therefore, Vy will be equal to 0, and we can just do simple rearrangement of the equation to give us gt is equal to u sine theta. Therefore t is going to be equal to u sine theta divided by g. So that gives us the time at which the projectile is going to be at its highest peak. So let's just find what height does it actually reach. So that's just h. Let's call that hm. So height maximum. That is just going to be x is equal. Now to find the maximum height the projectile will reach, so that's at tm, we're going to plug t into the equation for y. So that gives us y is hm, which is equal to u t sine theta. Now we're going to change t into u sine theta divided by g. So that gives us u sine theta square divided by g minus g into, again, so this is going to be the g t square divided by 2 term. So here it's g u sine theta whole square divided by 2 g square. So this cancels out with this, and we can simplify it as it goes. Therefore, our final equation comes out to be u sine theta whole square divided by 2g, and that gives us the maximum height that the projectile will reach. So the projectile is thrown at this speed, at this angle, it will reach this height at maximum. Now, since this is symmetric parabola, we can just multiply this by 2 to get our total time of flight. So that would be TF, so that's the total flight time, equal to 2 u sine theta divided by g. As simple as that. Now, to find the range, we have to use the total time of flight in this. Now, we have found the total time of flight of the projectile. We have found when it would be at its highest point. We have found what the highest point actually would be. All we need to find is how much distance it would actually travel, also known as the range. So the range would be pretty simple here. It would simply be the position x at time tf. So that's when the projectile is completed in the entire course of its trajectory. So we just plug in tf in the formula for x, and you get u into tf is 2u sine theta divided by g into cosine theta. So this is nothing but u square 2 sine theta cosine theta divided by g, and that gives us, and if you know your trig identities, you would know that 2 sine theta cosine theta is nothing but the expansion of sine 2 theta. So this is just sine 2 theta divided by g. Those are all the equations, and those are all the derivations for the equations you would need to understand projectile motion.